Gas exchange is the major purpose of the respiratory system. Inhaled air unloads oxygen and picks up carbon dioxide in the alveoli of the lungs, while the blood picks up oxygen and unloads carbon dioxide. The oxygenated blood then travels to body's tissues, where the reverse process happens. In the lungs, the gases move across a very thin respiratory membrane, which consists of alveolar squamous cells, endothelial cells of blood capillaries, and their fused basement membranes. The exchange of gases occurs due to simple diffusion as they flow down their concentration gradient or partial pressure gradient. Atmospheric air is a mixture of gases, each of which independently contributes to its total pressure. The pressure of each individual gas is known as partial pressure. The atmospheric pressure is the sum of all partial pressures of gases that make up its content. The direction of gas movement from one area to another is determined by the difference in its partial pressure. A gas always moves from higher to lower partial pressure. Atmospheric air is brought into the lungs through inhalation, but the lungs are not completely emptied and replaced with outside air with each cycle of breathing. In fact, only a relatively small portion of air in the alveoli is refreshed with each breath. This makes the air composition in the alveoli significantly different from that of inhaled air. The gas exchange in the lungs occurs between this alveolar air and the blood in capillaries. Because the volume of blood in pulmonary capillaries at any moment is much smaller than the total volume of air in the alveoli, the gas exchange process essentially brings partial pressures of oxygen and carbon dioxide in the blood to the same levels as those in alveolar air. It is therefore important that the composition of alveolar air is closely monitored and adjusted to maintain the same values. The body does just that. If carbon dioxide levels increase or oxygen levels drop, the airways automatically dilate to bring them back to normal, and vice versa. Since gas exchange occurs between the air and the liquid of the blood, the movement of individual gases also depends on their solubility in water. This explains why nitrogen, despite being plentiful in atmospheric and alveolar air, does not diffuse much into the blood. Factors that affect gas exchange include the magnitude of partial pressure gradient. The greater the pressure difference, the more rapid the gas movement. At high altitudes, where partial pressures of all atmospheric gases are lower, the gradient for oxygen is smaller and it needs more time to diffuse into the blood. The thickness of the respiratory membrane. The thinner the membrane, the faster the gas diffuses. Diseases that cause pulmonary edema, such as pneumonia or left-sided heart failure, increase the thickness of respiratory membrane and hinder gas exchange. The amount of gas exchange is directly proportional to the contact surface between the blood and the alveolar air. Diseases that affect alveolar surface, such as emphysema, reduce gas exchange efficiency and produce low blood oxygen levels.